Assalamualaikum dan salam sejahtera. Apa khabar semua? Diharapkan anda semua sihat sejahtera hendaknya dan selaku pelajar semoga anda diberikan kesejahteraan, kelapangan dan kemudahan dalam menuntut ilmu, insya-Allah. Bagaimana dengan sesi pembelajaran online semua? Diharapkan semuanya okey dan dipermudahkan ya. Amin. Baiklah, insya-Allah pada hari ini kita akan meneruskan program Meka dan Lepton semester 1 tahun 2020 anjuran unit Fizik Kolej Matrikulasi Melaka. Dan pada hari ini kita akan meneruskan program ini bagi siri yang ke-6 di bawah tajuk kegravitian atau gravitation, iaitu chapter 7. Sebelum itu, izinkan saya Sejejai selaku moderator pada kali ini untuk memperkenalkan pensyarah pembimbing bagi program kita pada hari ini. Dan insya-Allah pada hari ini kita akan bersama dua orang pensyarah muda dari unit Fizik KMM, merupakan antara pensyarah program PPC iaitu program pelajar cemerlangan. Jadi kita amat beruntung kerana mereka sudi untuk menjadi pensyarah pembimbing kita pada kali ini, dan diharapkan pelajar-pelajar dapat mengambil peluang ini untuk menimba sebanyak mungkin ilmu-ilmu yang bakal dikongsikan. Dan untuk itu pensyarah pembimbing kita pada hari ini adalah tidak lain tidak bukan. Yang pertamanya adalah Madam Nur Syafiqah binti Amaruddin dan yang keduanya adalah Madam Nurun Ainajwa binti Nordin. Ya, jadi diharapkan pelajar semua telah bersedia dengan nota dan alat tulis agar dapat diberikan tumpuan yang sepenuhnya sepanjang program ini berlangsung. Jadi dengan ini saya mempersilakan Madam Syafiqah untuk memulakan program ini. Dipersilakan.
Hi and Assalamualaikum everyone. I'm Madam Syafiqah. So today we will discuss chapter 7 on topic gravitation. Okay, so before we start to discuss about the questions that related to chapter 7, so let's look at through the subtopic. So 7.1 is about gravitational force and the field strength, and the equation is Fg equal to gmm over r squared, where the gravitational field strength, the equation is Ag equal to gm over r squared. And then we have gravitational potential energy, on subtopic 7.2. Alright, and the last subtopic is satellite motion in a circular orbit. So we have escape velocity FVE, square root 2gm over r squared, and also the tangential velocity, and the last one is about the period t, which is the time taken for the satellite to orbit around the earth. Okay, so the equation is given like this after the derivation. Okay, so now let's discuss some questions that related to this chapter. Okay, so now let's start question number 1. Okay, so read the question first. So figure 4 shows a mass M1 position between two masses, M2 equal to 40 kg. Alright, so M2 is 40 kg. So this is M2, and M3 is equal to 60 kg. Okay, so this is M3, 60 kg. Okay, and the distance between M2 and M3 is given 15 meter. Alright, so I want to take out all the information given. Okay, so we have M2 equal to 40 kg, we have M3 is equal to 60 kg, and the distance between 2 and 3 is 15 meter, but the distance between 2 and 1 is given x. Okay, we don't know what is the value of x. So now question number 1. Okay, so sketch and label the forces acting on mass 1, M1 due to M2 and M3. Okay, so question number 1. Okay, you must focus on which mass. So on mass 1. Okay, due to M2 and M3. Alright, so we have mass 1 here, M1. Alright, so M3 is, okay, on the right of M1. So M3, so this one should be to the left. Okay, so the direction of the force on 1 due to 3, sorry, to the right. Okay, to the right. F13 is to the right. Okay, and the force on mass 1 due to mass 2 is to the left. Okay, so let's say we have here, M3, okay, and here we have, okay, M2. Okay, so the direction of the forces acting on mass 1, okay, F13 is to the right, F12 is to the left. Okay, second question. Okay, let's say second question. Okay, determine X when M1 will experience zero net gravitational force. Zero net gravitational force on M1. Okay, so that's mean the net gravitational force on M1 is equal to 0. Okay, so you must know this first. Okay, so this is the concept. Okay, the total or the net gravitational force on mass 1 is equal to 0. Okay, so we need to write total gravitational force, okay, on 1 is equal to 0. Okay, so we have F13 to the right, so positive, plus, so total F12 is to the left, so the direction is negative, so is equal to 0. Alright, so now we try to rearrange the equation. F13 equal to F12. Okay, where F13, okay, this is gravitational force, okay, on mass 1 due to mass 3. Okay, and this one, okay, this is gravitational force on mass 1 due to M2. Okay, so when you write like this, so this can avoid you to do mistakes when you want to substitute the value of M1, M3 or M2. Okay, so now say, okay, remember, okay, so now remember the equation. Okay, the equation F equal to G mm over R squared. Okay, now let's substitute the gravitational force on mass 1 due to M3. So G M1 M3 over the distance between R13 equal to G M1 M2 over R12 squared. Okay, kita tertinggal squared. Okay, so now look at here. We just have the distance of R23, R21. So how about R13? Okay, so this is the distance between 1 and 3, mass 1 and mass 3. Okay, so the distance between mass 1 and mass 3, so R13 is equal to 15 meter here, okay, minus x. Okay, so it should be 15 minus x. Okay, so you can just substitute, but this one we can cancel G, we can cancel M1. Okay, what else we can cancel? That's all. Okay, so now M3, so we are given the mass of M3 is 60 kg and the distance of R13 is 15 minus x squared. Okay, equal to M2 is 40 kg over, what is the distance between 1 and 2? It is x squared. Okay? Alright. So now, make sure, okay, you rearrange the equation. Okay? Don't expand the quadratic equation. Okay, look at here. We have the power of 2, the square of x, and 15 minus x. Okay? Okay, bring it to the other side here. Okay? And 60 down. Okay, moving down. Okay, so now we have x squared over 15 minus x squared equal to 40 over 60. Okay, so in order to simplify this equation, okay, we can take the square root for the both side. Okay, because I want to cancel the square. Okay, so you can cancel here. We can cancel here. Alright, so now we can write as, okay, x over 15 minus x equal to, okay, press your calculator, 40 divide 60. Okay, so the answer is 0.8165. 0.8165. Okay, so now you can rearrange the equation. Okay, we have x here, 0.8165, 15 minus x. Okay, so x is equal to 0.8165 times 15. So 12.2475 minus 0.8165x. Okay, so now we can calculate x. So x is equal to, okay, please calculate with me, 1 plus 0.8165. Okay, so now 12.2475, divide the answer. Alright, so the answer is 6.74. Okay, so now determine x when M1 will experience zero net gravitational force. So now, okay, we have calculated x. Okay, where x is equal to 6.74 meter from M2. Okay, alright, so now let's proceed to question number 2. Okay, so now let's try to solve question number 2. Okay, read the question first. Okay, the first one, calculate the acceleration of Earth gravity where the distance is 500 kilometer above the Earth's surface. Above the Earth's surface. Okay, the radius and the mass of the Earth are 6.4 exponent 6 meter. And the mass is 5.98 exponent 24 kg. Okay, so when we try to sketch the position, okay, so let's say this is the Earth. Okay, this is on the surface, but now we want to find what is the Earth gravity 500 kilometer above the Earth's surface. So somewhere here. Okay, so I put this as h. Therefore, the distance from the center of the Earth would be r is equal to re plus h. Okay, so r of the Earth is given 6.4 exponent 6 plus h is equal to 500 kilometer. Okay. Sorry, 500 exponent 3 meter. Okay. So R is equal to, okay, let's calculate together. 6.4 exponent 6 plus 500 exponent 3. Okay, so we have 6.9 exponent 6 meter. Okay, so now the mass is given. Okay, so the mass of the earth, okay, I want to put it as capital M. Okay, mass of the earth 5.98 exponent 24 kg. Okay, calculate the acceleration. So G, we want to find what is G. Okay, so question number 1. So let's say I put it as question number 1. Okay, so G is equal to, because we want to calculate what is the earth gravity at that position. Okay, let's say we put it as position P, okay, at point P. So we want to calculate what is the earth gravity at point P. Okay, so okay, I like to write like this one, GP, earth's gravity or gravitational acceleration at point P. Okay, so G equation is G M, the mass of the earth, over R squared. Okay, so now it's equal to, okay, G is equal to 6.67 exponent negative 11, where the mass of the earth is given 5.98 exponent 24. Okay, and R kita dah kira tadi. Okay, we have calculated just now. 6.9 exponent 6, jangan lupa square. Okay, so okay, try to calculate. So we have 8 point, so GP 8.38 meter per second square. Okay, so this is the answer. Okay, so the question asks you to find, okay, acceleration of earth gravity. Okay, so acceleration of earth gravity at point P is equal to 8.38 meter per second square. Okay, now let's proceed to the second part of this question. Okay, a satellite orbits the earth in a period of 24 hours. Okay, so we have a satellite where the satellite orbiting the earth, okay, and the period, okay, so the period means that this one time taken for one complete circle, okay, which is equal to 24 hours. Make sure you change 2 seconds. Okay, so that it is always at the same point above the earth's surface. Calculate the radius of the orbit. The radius and the mass of the earth are 6.4, okay, exponent 6 meter and 5.98 exponent 24 kg respectively. Okay, so as we know, for question number 2, okay, so the position of the satellite, so let's say this is the earth. Okay, so this is the center. So we have the radius of the earth here. Okay, so now let's say this is the position of the satellite. Okay, so the satellite orbiting the earth at position of, okay, we don't know what is the position. Okay, so I just put here as H. Okay, and R is equal to RE plus H. Okay, so the question asks you to find R. Okay, calculate the radius of the orbit. Okay, we want to calculate R. Okay, so equation of T, so let's apply equation of T. So T is the period for one complete circle. Okay, ataupun 2 pi R3 over GM. So this is the equation. Okay, sorry, so you can straightly use this equation. Okay, so now we rearrange the equation. So take squared for the both side, okay, in order to eliminate the square root. Okay, so now we have t squared equal to 4 pi squared r cube over gm. Okay, so now we can try to rearrange the equation. So R3 is equal to t squared gm over 4 pi squared. So R, okay, t squared, okay, gm over 4 pi squared 1 over 3. Okay, okay, so use your calculator to calculate R. Okay, make sure you substitute, okay, all the unknown with the correct values. Okay, so let's try to substitute. So t squared, okay, remember, so t is given in hour. Okay, you need to change to second. Okay, so remember, t is equal to 24 hours, where equal to 24 hours times 1 hour is 60 minutes. Okay, so 1 minute is 60 seconds. Okay, so you can cancel. So 24 times 60 times 60. Alright, so 24 times 60 times 60 to 86400 second. Okay, so now you can just substitute. Here we have 86400 squared, okay, where g is the constant, universal constant, 6.67, exponent negative 11, and the mass of the earth is given 5.98, exponent 24. Okay, so close the bracket, 1 over 3, okay, and this is 4 pi squared. Alright, take your calculator. Alright, take out your calculator and press your calculator carefully. Then finally the answer is 4.23 exponent 7 meter. Okay, that's all. Alright, so now let's proceed to question number 3. Okay, so let's proceed to question number 3. So read the question first. So I put this one is A and this is B. Okay, so question A. A satellite is placed in an orbit at a distance of 4.23 times 10 power of 7 meter from the center of the earth. From the center of the earth. Okay, so the distance here is from the center of the earth, not from the surface of the earth. Alright, not above the surface, but from the center of the earth. Calculate the speed of the satellite. Okay, so we want to calculate we want to calculate what is the speed of the satellite. So A, okay, so let's say we have, okay, alright, so the line should be from the center to the position of the satellite. Let's say this is the satellite. Okay, we're given that the radius R is equal to 4.23 exponent 7 meter. Okay. So, in order to calculate what is the speed of the satellite, okay, we can use equation. V is equal to square root gm. So here we have the Earth, so mass of the Earth, and R. Okay. So we can straightly substitute the equation. Okay, substitute all the values in the equation. So G is the constant, 6.67 exponent negative 11. Okay. So this one is, okay, should be good line. Alright, so mass of the Earth. Okay, so mass of the Earth we use, okay, let's say mass of the Earth 6 Jadi kita pakai berapa? Okay, here we have 5.98. So let's say I use 6. Okay, let's say I want to use 6 exponent 24. Okay, over 4.23 exponent 7. Okay, so okay, try to calculate the value. So V is equal to 3075.9 meter per second. Okay, make sure you write the correct unit. Okay, so this is the answer. Okay, so how about B? Okay, look at question B. Okay, if the mass of the Mars is 0.107 times that of Earth, okay, so let's say the mass of the Mars is given 0.107 the mass of the Earth. Okay, and its radius, the radius of the Mars is 0.530, okay, to the radius of the Earth. Alright, so this is the information given by the question. Estimate the gravitational acceleration at the surface of Mars. Wow, we want to calculate what is the gravitational acceleration G at the surface of Mars. Okay, alright, so now let's say this is not the Earth. Now we have Mars. Okay, and this is the radius. I put as RM, means that for the Mars. Okay, so on the surface, okay, we want to calculate what is the gravitational acceleration G here. Okay, so general equation for gravitational field strength or gravitational acceleration on the surface. Okay, we can calculate G. Okay, I put as GM. M stand for Mars, is equal to GM over R squared. Okay, so this should be the mass of the Mars. Okay, so this is the equation. Okay, so now substitute all the values. So G is 6.67 exponent negative 11, and the mass of the Mars is given 0.107 mass of the Earth. Okay, this is the ratio. Okay, 0.107 the mass of the Mars, the ratio of the mass of the Mars to the mass of the Earth. Alright, so how about the radius? The radius here should be the radius of the Mars, where 0.530 the radius of the Earth. Okay, so now we can just substitute the value. Okay, or else you can simplify. Actually, you can simplify. Okay, so I want to write like this. Okay, look at here, we have G ME over RE. Okay, so 0.107 over 530. You still can substitute the mass of the earth or the radius of the earth here. Okay, yeah, you still can substitute the mass of the earth and the radius of the earth, but now I want to rearrange this equation so that I got a new equation here, GME over RE, where this is the gravitational acceleration at the surface of the earth, which is 9.81. So we do some mistake here. We should put square here. So square, so this should be square, and this is also square. Remember, square. So let's highlight. And this one should be square. So 0.530 squared. I try to write again. I try to write again with the black pen. Oh, sorry. So 9.81. So this should be times 0.107 divide 0.53 squared. So 0.3809 times 9.81. So the answer is 3.7. I got 3.73. 3.73 meter. Or you can substitute. Or you can substitute here. 6.67 exponent negative 11, 0.107 mass of the earth, let's say 6 exponent 24 over 0.530 times the radius of the earth, 6.4 exponent 6 squared. So the answer would be, so let's try to calculate. So 6.67 exponent negative 11 times 0.107 exponent 24. The right answer. So the answer here is 3.72. So either you can choose to substitute 9.81 or you can do like second part. You still get the same answer. Alright, so that's all from me. So we will continue to solve some problems with medium Nurun Ain Najwa. So thank you for your attention, and I wish you all the best for your PSPM. So that's all. Thank you.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Hi guys, nama saya Madam Ain Najwa. So hari ni kita akan discuss 3 soalan pasya question chapter 7 Gravitation. Jom kita tengok. PSPM 2016-2017 number 4C with 7 marks. So we have 3 questions. 1 is state Newton's law of gravitation. 2, sketch the graph of gravitational field strength against R with gravitational potential against R. And number 3, we need to calculate the period. Okay. So what is meant by Newton's law of gravitation? The magnitude of an attractive force between 2 point masses that is directly proportional to the product of their masses and inversely proportional to the square distance between them. Okay, next is sketch the graph of gravitational field strength AG against R from the surface of Earth. So we have Earth here. Okay, so AG, what is the formula of AG? Kita tengok bumi ni pusing-pusing. Mana ni AG? AG sama dengan apa ya? AG tak keluar lagi equation. So when R is equals to RE, AG is equals to GM over RE squared, where it is equals to G, which is equals to 9.81 meter per second squared. And when R is greater than RE, AG will be equals to GM over R squared, and it will be inversely proportional to the distance square of it. So AG directly proportional to 1 over R squared. Okay, so what would be the graph of AG against R? Alright. AG against R. So we sketch x-axis R. Don't forget to label R with the unit meter. And for y-axis, it is AG. What is the unit for AG? It is ms negative 2. Alright, so when R is equals to RE, AG is constant, which is equals to 9.81 meter per second squared. Okay, how about when R is greater than RE, the graph will be inversely proportional. Okay. Alright, okay, cantik graph. Okay, so kita check label x-axis, y-axis, unit, and then label 9.81, R equals to RE, graph, bentuk graph, okay, semua cantik. Alright, full mark for this question. Okay, so kita bagi thumbs up. Next, second question. Sketch graph of gravitational V against R from the surface of Earth. So we have x-axis R labeled with the unit meter, and then for y-axis it is V with the unit joule per kg. Okay, graph for R greater than RE, V is directly proportional to negative 1 over R. Okay, so when R equals to RE, V is equals to negative GM over RE. So the last question, the period of a moon orbiting Pluto is 4.8 days. The radius of the orbit is 4 times 10 power of 7 meter. Calculate the mass of Pluto. So what is the formula for period? T equals to 2 pi set of R cubed over GM. Given that T is equals to 4.8 days, so we change to SI unit where the SI unit is second. So 4.8 times to 24 times to 60 times to 60, we get 414,720 second. Okay, so we already find the period in SI unit. Now we need to find the mass. So from the equation, we rearrange the equation to find mass. Okay, let M as a subject. Okay, rearrange the equation. We square both sides. We will get T square equals to 4 pi square times 2 RQ over GM. Okay, pusing-pusing kita dapat M equals to apa? 4 pi square R cube over T square times 2 G. So do we have all the information here to find M? We have T, we have R, and we also have constant G. So we can substitute the value 4 pi square. Ada square di situ sebenarnya, tertinggal. Times 2, 4 times 10 power of 7 cube over 414720 bracket the square times 2 6.67 times 10 power of negative 11. Saya buat kat bawah tak muat. So the answer for mass is equals to 2.2 times 10 power of 23 kilogram. Okay, so formula substitution unit semua ada. Alright, okay, good. Settle for this question. Okay, the next one is PSPM 2017-2018, question number 4B. Okay, so 4B, the question is apa ya? Ni. The International Space Station is launched from the Earth and orbiting at an altitude of 350 km. Sketch and label the variation of gravitational potential against distance from the surface of the Earth experienced by the ISS during the journey. So we need to sketch graph of V against R. So basically this question is the same with the 2016-2017 question. So we just copy the slide. Okay. Copy the slide and label. Sketch axis X and Y. X is referring to the distance R. And don't forget to write the unit meter. And Y axis is V, potential. And what's the unit of V? Is it joule? It is supposedly joule per kg. Okay, after this keluar kot unit dia. Okay, when R is equals to RE, we know that our potential will be equals to negative Gm over R. And for the graph of R greater than RE, okay, V is inversely proportional to the negative R. So the shape of the graph is the red line. Okay, done. Okay, number 2. The ISS has a weight of 4.22 times 10 power of 6 Newton when it is measured on the surface of the Earth. So, given the mass and radius of the Earth is 5.98 times 10 power of 24 kg and 6.38 times 10 power of 6 meter respectively. So, calculate the weight of ISS when in its orbit. Okay, so at the orbit, what will be the weight? So the weight at the surface of Earth is 4.22 times 10 power of 6 Newton. So at this orbit, what would be the weight of this ISS? Okay, so how to find this weight? We know that W is equals to mg. So the gravitational acceleration at the orbit there is not equals to 9.81 meter per second squared. We need to find the AG at this orbital first. Okay, list out the information WE, ME and RE. So we need to find this W. So we let at this orbital it is equals to x. So Wx will be equals to mass of the ISS times 2 at point x. So we find ms first by using equation WE equals to ms AGE. Okay, we will get mass of the ISS is equals to 4.3017 times 10 power of 5 kg. And then we need to find the A at point X. Okay, what is the formula for AX? Gravitational acceleration is equals to gm over r squared. So r is equals to re plus to the altitude from the surface of Earth, it is 350 km. So we get 8.728 meter per second squared. So we have all the information, and then we can find weight at the orbit. Wx is equals to ms times 2agx, where ms, m of ISS study is equals to 4.3017 times 10 power of 5 times to 8.728. So it will be equals to 3.75 times 10 power of 6 Newton. Alright. Okay. The last one, PSPM 2019-2020, which is question number 7. A 120 kg satellite is orbiting the Earth at an altitude of 190 km. The radius and mass of Earth are 6.4 times 10 power of 6 meter and 5.98 times 10 power of 24 kg respectively. So we have Earth here, and then satellite. What is the satellite? Where are you? Satellite dia belum launch lagi. Okay, kita tunggu dia baru setting tu dekat surface of Earth. 3, 2, 1. Okay, belum muncul lagi satellite, belum ada lagi. 3, 2, 1. Yes. So we have satellite. Okay, that have been launched 290 km from the surface of Earth. So A, we need to find the gravitational potential energy of the satellite, which is 3 Mach. Okay, so we need to find U. So list out the information. We have RE 6.4 times 10 power of 6 meter, mass of satellite 120 kg, mass of Earth, and then so R will be equals to 6.59 times 10 power of 6 meter, where R is the addition of RE plus 2 altitude. So substitute into the equation, U equals to negative GMM over R. So 6.67 times 10 power of negative 11 times 2 5.98 times 10 power of 24 times 2 120 divided by the R. So remember, your R supposedly from the center of the Earth to the location of the satellite. So finally, we get U equals to negative 7.26 times 10 power of 9 Joule. Okay, so done for question A. B, we need to find the period of the satellite. 2 marks. So the formula for T is equals to 2 pi times 2r cube over gm. Jangan lupa ada square root. Square root of r cube over gm. So we substitute the value since we have all the information. 2 pi times to set of 6.59 times 10 power of 6 cube divided by g. 6.67 times 10 power of negative 11 times 2 m. 5.98 times 10 power of 24. Jangan dilupakan square root. So the answer for T period, it is equals to 5322 second. Okay, done. Okay, ni apa ni tiba-tiba delta V? Oh, last question C. Change in the speed of the satellite for it to break free from the orbit. So change in speed. That means we need to find delta V. So firstly, we find the V satellite at the orbit first. The formula for V is equals to gm over r, set of gm over r. We substitute the value. We have all the information. We get V equals to 7.78 times 10 power of 3 meter per second. Okay, speed to break free, that means it is equals to the escape velocity, where the formula for escape velocity is equals to set of 2gr. So we substitute all the information. We get VE equals to 1.137 times 10 power of 4 meter per second. Okay, remember we need to find the change in speed. So V escape is greater than V orbital, minus it, and we get V equals to, delta V equals to 3.959 times 10 power of 3 meter per second. Okay, that's all for.
Alright, done for question C. Alright, Alhamdulillah dah selesai dah semua 3 soalan partial question topik gravitation. So saya harap ia dapat membantu awak untuk faham lebih topik ni. That's all from me. Thank you guys. Bye. Assalamualaikum.
Baiklah, demikian tadi sedikit perkongsian ilmu bagi bab 7 Gravitation bersama Madam Syafiqah dan Madam Ain Najwa. Terima kasih diucapkan. Diharapkan semuanya jelas dan semoga kefahaman ini membantu pelajar untuk memperolehi A dalam subjek fizik bagi PSPM yang bakal menjelang tidak lama lagi. Okey, jika ada sebarang kemusykilan, pelajar bolehlah bertanya terus kepada pensyarah tutorial masing-masing melalui WhatsApp group atau Telegram group yang sedia ada sebelum ini. Jadi, rungkaikan segala ketidakfahaman, kukuhkan segala konsep yang ada. Ingat, tiada kejayaan tanpa sebarang usaha. Dan kejayaan itu akan lebih manis rasanya jika ianya disulami dengan perik jerih usaha tanpa henti. Jadi sekali lagi terima kasih diucapkan kepada semua yang terlibat dalam program Meka dan Lepton semester 1 tahun 2020 anjuran unit fizik KMM. Jadi link borang kehadiran akan dikongsikan di sini sebentar lagi dan mohon kepada semua pelajar yang mengikuti program ini untuk mengisikan borang kehadiran tersebut. Okey, jadi kepada semua, ingat kita jaga kita, pastikan penjarakan fizikal dipatuhi dan sentiasalah menggunakan topeng muka ketika berada di luar rumah. Dan ingat, ke mana saja kita pergi, bawalah sanitizer bersama. Okey, jadi insyaAllah kita akan bertemu semula di program yang sama untuk siri yang ke-7 nanti. Jadi kita berhenti di sini. Sekian, terima kasih. Assalamualaikum. Bye.